Welcome to our channel. Today we will see how to download climate data using Linux terminal, and in addition to that, extraction and analyze climate data using climate data operator or CDO. So here now we want to download climate data from different sources. So we can open first a terminal, Ubuntu terminal. So this is an Ubuntu terminal. When you can see that the path is pwd, this is the path which is the directory allocated on the desktop. So now we should have to see this directory where it is found. Just the desktop, just simply here when you can click, we can see the analyzing data in climate CDO directory. Here we can have this directory on the desktop. So now we want to download the data on this directory, So to do this, we can copy the link, which is the source from now, and wget minus c the website of the NOAA data. The NOAA data is here. We tried to, as an example, to download the soil moisture data, which has a 0.5 grid resolution. So we can copy here, we can copy this, and we can paste here. Copy, paste here. Now when you can see that, just you should have to adjust here minus c value. Just it starts downloading the data, the soil moisture monthly, the long term, almost from 1940 to the present time data is available. So the download is completed here, as you have seen. So when you can see in the previous time, we're in this folder, we do not have this such file. After downloading the data, just we had got the soil moisture data here. So now we try to see this soil moisture data, different informations. To see this data content is just simply we can write that nc dump minus h, and also the name of the variable, which is soil moisture. Now this indicates for us, we can see that various informations here. Various information we can get that means the source of the data, the resolution of the data, the time steps, and latitude, longitude, coverage of spatial and temporal coverage of this area can be seen here. So through using nc dump, we can see that the information of the file, file of the nested data. So you can see that longitude, latitude, time, and in addition to that, end bands. So, and also you can see whether it is monthly, daily data. Just you can identify even the source of the data, CPC, monthly soil moisture, and the unit. You can check it here also, the unit of the soil moisture, Here we can see that soil moisture units and different parameters, even including missing values also. You can see further informations from here. So if you want again to download another source of data, for example, if you want to download Eclipse data, we can use this link. Using this link, we can download Eclipse data also on our terminal. So this chirps data, it is very high resolution. It is resolution is 0.05. To download it takes a long time. So maybe as an example how it can download, simply I can show. Now it starts downloading, as you have seen here, but it takes a long time to download. It is about 6.6 GB data, so it takes a long time and it needs a strong connection as well. So I should have to interrupt it. So now the next step is we want to see the downloaded data, which is the soil moisture monthly data, to see further information about this soil moisture data. For example, to see this uh, information, again, we can see the CDO info info B. So just you can type and enter, you can say. Just you can see the information contents here. You can see the information it contains, the information that it contains. So the monthly long term you can see here. Yeah, well, you can see this is the long term data, which is uh, we downloaded the soil moisture. Now, when you can see that a long term rather than long term, just we can use that mean monthly data. So to see further information, this one is better. So now it starts downloading. So we'll wait until it completes the downloading. So using freely available different data sources are very important for monitoring climate. Also, so it requires further works. Therefore, we can give an emphasis, especially for high resolution data, such as CHRIPS data. Tomsat and so on are very important for to analyze different variables. That mean, especially the Tomsat contains different variable chirps data source. The chirps is it is a precipitation data. So this data is a very high resolution data. We can find just this data in different ways, the daily basis, monthly basis, and the yearly basis also. Even we can analyze using CDO any area of the data source. So now when you can see that the download is already completed, now we want to see CDO info info n. So when you can see that info n, the soil moisture of the monthly mean data, when you can see that we can have this type of just data, we will see this type of this data is a very long months data. It has almost a large number of time steps, almost the time steps, where you can see that it has about 922 time steps. So when you see here, what we can see the data contains here the minimum value, the maximum value, the mean value and the maximum values and the parameter name, which is indicates for us. Just here is a parameter name, as we have seen. So the date is starting from 1948-01 to that of it extends to recent months, which is as we have seen here 24 the 10th month. So it's very long year data. Therefore, just we had got some information about grid data, what it looks like here. And in addition to that, we will see, since this data is very long data, we want to see just how we can extract a data, for example, the climate data. So if you want to extract the data based on year, if you want to extract, for example, the 1984 data of soil moisture monthly mean data, we want use a CDO operator. So using CDO operator, CDO, here copy to save the time. Here we can write CDO and also just we can paste here. So here is what we can see. Failure indicates for a select year. We want to select the year, which is the 1984 year. Just if you want to select this, just how we can see here, enter. When you can see that here it indicates some error here. Soil mon.min.nc, no such file size, no such file in this directory. So let's see that either it is not available or yes. So ls here when you can see soil mon, just we can have here this data. So what we missed here, the name of the soil moisture here. So we should have to write the appropriate name. So here now we should have to mean, and the next is which is p2 out, and then we can enter. Now we should have to work. Already it is working, but it shows for us a warning. So we should have to remove this warning by typing. For example, let's take that we should have to use this code, and we can adjust as a band here. So here, copy, and here we should have to paste this value. And then what we should do, we should have to take this value as it is, and we should have to write in this way. And also we can give a name. For example, let's say soil mon me.nc. So we can write in this way, and then the error should have to be corrected now. So now we should have to proceed to the next steps to extract the data, the 1984 data from the original data. So soil here mon me.nc. So here is now it's okay. So we can extract the data without error. Now we can't see any error. just this data is simply extracted the data as a 1984 data, yearly data, the monthly data in it, simply extracted as we have seen. So when you can see that ls, just we see here the 1984 data here, the 1984 data. So simply copying this, just cdo info n, here we can paste it in there. We will see here starting the first month of 1984 to that of the last month 1984, we have a data of soil moisture, the soil moisture content. Here is you can see how we can extract a data based on yearly. However, here not only a single year, we want to extract multiple years using CDO. To do that, we can see here select single years, for example. Alone we can select, for example, 1984, 1985, and also 86, including this one. We want to select the data. We want to select the data. So to select these consecutive years, what we should do, CDO said year, from just we can select years 1984, 85, 86 as a monthly mean soil moisture, and we can write it this way. Now we can copy this value, copy. So here we should apply just again this value, which is a corrected value, soil mole main value. So here is. Now the extraction is completed. When you can see that in the previous time we do not have such type of data, just we will see in our directory this data as well. So this way. But we can have other options also. We can have other options of extracting multiple years of data. For example, if we want to select again this years, we can write in this way. Similarly, we can get similar data information. So just copying this term, and then we can paste here. Copy. And then paste here. Again, this data is arranged in the previous time. So now we may put here another name. For example, just to separate from the previous one. Just enter. Now it is processed, and that's when you can see that. Just we can get this data also. So these two data are similar. These two data are similar data, but what is the difference is the way that we select year, the procedure that we follow to select years. For example, let's see as an example, CDO info n. We can insert this value. Enter. You can see from 84 to 86, and in addition to that, we can see that the same result for the previous other values also. There is no difference, but only the way that we select the time steps, So the next step is what we can see here. Is the region. For example, we want to select spatial coverage area, some parts of region. To select that some parts of region, we should have to based on latitude and longitude. So there is initial latitude and the final latitude, and also the initial longitude and also the final longitude. Based on that, we can extract a data. As an example here, we selected the region of Ethiopia. We selected Ethiopia region. So the Ethiopia region, which is allocated from 33 to 48 longitude and 3 to 15 latitude, we want to extract this soil moisture in the region of Ethiopia, So what we should have to do here, we can copy this data, and after we copy, then we can paste this data here. Let's say clear data, and here this should have to be corrected. So Ethiopia region data we want to extract. So here is the extraction is started now. Almost the extraction of the data is already completed. So when you can see this the Ethiopia region data, if you want to the time series minimum maximum values, we can see the data CTO info v, for example, info a possible page. So here now this operator capable of this name, and we can use as an operation fn. Now it's working. Just this is the region of the Ethiopia data source of soil moisture, so based on monthly, starting from 1948 to that of 2024, the 10th month. So we can extract data in time, based on time, and also space as well. As we have seen here. The other is what we can see here. If you want to select a region and some interval of time or some interval of years, we can apply this CTO code. So we can copy this. This indicates for us this is select here. We can select here, and we can select also latitude and longitude to get a region. And in addition to that, we can select a year to get a period interval that we want to get a time interval for that region of climate. So here we can copy this data. Directly and paste to the terminal. Copy and paste here. Just we should have to avoid this. So again here soil map. Now just we extracted from 48 to 2023 year data, or if you want to change this data as possible, for example, if you want to 22, let's say 22, and if you want to extract the data starting from 1970, let's say 1970 to 2022, we want to extract a region data of the monthly mean soil moisture data. So that now processing is started. The processing is already completed. That's the data that we had got is this data. Just we can see here the data which is Ethiopia region 19. Just we can adjust this value also. The name that we can used maybe it's better rather than using this should have to be 22, and we can put here 70. So now you can put here enter. So when you can see ls, we had got the data here. As we have seen, this is the data. This is the data which is extracted based on region and time period. So even when you can see that our directory here, we can see these results. This result as you have seen here. Here are the results that we did now, including this one also, and this also. Therefore, here we can extract a data based on time and also space. And in addition to that, both space and time simultaneously. The next step is what we can see that we want to see the data in tabular form or in table form, which is an ASCII. We want to convert the Netcdf data to that of the ASCII. To do this, we may use the single year to see the latitude, longitude. Here you can see that the name of the variable and year, months, days, if it is daily basis data, longitude, latitude, the values. So, for example, for 1984 Netcdf data. So to do this, what we can do here, we can copy this data, and also we can paste on the terminal. Then maybe we can shift the name or change the name. Let's say 1984 point text. Even you can convert it to Excel. It's possible, you can do that. So when you can see filter here, so it's starting processing now. Takes some time. Now the processing is completed, so we will get this data. So even we can see here, but we can see on our directory now. Here, this is the value as you have seen here. This is the value that we extracted based on latitude, longitude, and also the value of the soil moisture. Even the missing value, how it can be denoted previously using NCDump, I showed to you, so you can refer that further information, the missing value, how it can be denoted. So here the name of the variable, the soil moisture, and the year, also months, and also days. So longitude and latitude as well, as we have seen. This part is which indicated for us. This one is the longitude values, and this one which indicates for us latitude, and this part is the what we call that the value of the soil moisture. Just you can see that some missing values, and also the value other values are available. The soil moisture values are available here. So this one is the soil moisture data, which is selected based on table, tables that we want to extract a specific year. If you want to extract specific year data, just we can extract in this way. The next is what we can see here, analytics part. the analytics part we can see. For example, if you want to calculate the mean of the temporal mean, and there is also a spatial mean, the spatial mean. So the time mean of historical data here, we can have a historical data as we have seen, just this historical data. For example, we can take the soil moisture of this data, soil moisture of this data. So we want to calculate the soil moisture, the time mean, and in addition to that, the spatial mean. So we should have to understand the time mean and also the spatial mean, what it indicates for us, spatial mean and time mean. Now we can see that the first time mean, what it indicates for us. The time mean, as you have seen here, based on historical data, that means from 1948, as you have seen, to that of 2024, the last 10 months, we want to calculate the time of the soil moisture data. So to do that, we can use this value, CTO. We can copy this value, copy, and we can paste here. Not working. I should have to repeat again. Now it's okay. Just we want to calculate the time of this data. Previously we corrected this data into this. So mean of soil moisture, which is time mean of soil moisture. So we can say enter here. It already calculating the time mean. It takes some time because long year data. So it already processed the data. You can see that the information, for example, CDO info n, CDO info n, T mean, just it indicates for us, just we can get that the average value of the minimum mean and the maximum value of the spatial, the temporal mean, which we can get here, the temporal mean, the data. The other is, we can see that FLD, the spatial data, what it indicates for us. So to do that, now we can use the next code, this code, FLD mean, indicates calculate yearly time series data. So here year mean of the spatial, using field mean, So we can type this code. So for field mean, we can use CDO field mean, and we can write that the data, previously the soil moisture data, which is based on monthly, and FLD mean, let's say soil .nc. So now we can say here enter. Now it starts processing. Almost finished. The next step is checking the data, the field mean, what it indicates for us. Like time mean, using time mean, previously we saw the data. What does the time mean indicates here? Also FLD mean of the soil moisture, what it indicates for us. So CTO info and FLD mean dot, which indicates for us NC. So we can say enter. Just we can see that the mean spatial using FLD. That means the spatial data, which is an average value. across each year, that means starting from 1948 to that of 2024, the last 10 months. Therefore, here what you can see is that the areal average data of the time series data we can see here. Thank you.